Hey guys, welcome to the part 2 of neural networks, where we're seeing what is a neural network. A neural network is just a multi-layered perceptron model, if you remember the perceptron model from the previous video. It's basically just a bunch of perceptron models combined into one single network. The outputs of one perceptron are fed as the inputs into the next perceptron, and you'll see an image of this on the next slide. This allows the network to learn about the relationships between features. So as you can see here, all of these circles are perceptron models, and they're all interconnected to form layers. So these are the parts of a neural network. The first part is the input layer. Basically, it's pretty self-explanatory. It's where the neural network takes in the inputs. Each neuron, which is the circly thingies, is a different feature or column. And there are the same number of nodes as columns in the data. Next, we move to the hidden layer, where the neural network does something to the input through highly complicated processes. In fact, it's actually really difficult to know exactly what it's doing, especially for really large networks, because these hidden layers are so far away from the input layers. This section is often known as the black box. And if there are two or more hidden layers, the model is called a deep neural network. And finally is the output layer. It's just the output of the neural network. For regression or binary classification problems, there's only one neuron since the model picks one of two available options, either a 1 or a 0, a yes or a no. But there can be more than one neuron in the output. It's usually for multi-classification problems where you have to categorize it into multiple categories. Next, classification. Our previous perceptron model was just a simple summation function f of x. If you remember, it was y equals x1 plus x2. But in classification, it would be more useful to have the outputs between 0 and 1. So we have two options, and we want to figure out which classification our input is. The closer an output is to 0 or 1, the higher chance it actually is that classification. For example, if the output was 0.8, then it would obviously be closer to 1, and if it was around 0.2, then it would be closer to 0. We'll see how to use activation functions to set these boundaries for the output values of neuron. These boundaries right now are 0 and 1, but we can vary those with activation functions. Also, just a disclaimer, these next few videos will be a lot more technical. But you can still implement neural networks without knowing the intricate details of how it works. But you should still check them out anyway, because they're really good. So I'll see you guys in the next video, where we'll talk about activation functions and how to set boundaries for outputs. See you guys there.